Hey guys, we're gonna make a pH foldable today. Just so you know, you need a red, a blue, and a green colored pencil, something to write with, and then a ruler. And so this is just gonna kind of help us out making everything nice for this pH foldable. And so the first thing we're gonna do is hamburger fold. And so that is like so. I have my paper in a landscape format sideways, and I'm going to fold it in half. Try to get it as even as possible. And so there's my hamburger fold. Oh, I got multiple recordings there. So as we hamburger fold, after you fold it, unfold it. So we're going to use this line in the middle. You will then take your ruler and somewhere on one of the inch sides, so the inches are the ones that are farther spaced apart, I'm going to put the ½ inch, so the one in the middle of two numbers, right on that fold. And I'm going to make a little line, just a tiny little mark, about 1 inch away from the other marks, or ½ an inch away from that center line. Everybody see it? So there's a ½ inch away from the center line. And what I'm going to do is fold each end to that the little mark I made. So I want like a 1 inch gap in between. And so I'm going to fold each side up to that mark, trying to keep everything even. And so that leaves me a 1 inch gap in the center. All right, so we got a 1 inch gap in the middle, ideally. And so we're going to put stuff inside these, in the middle, and on the outside. And so if you follow along the PowerPoint, it will kind of tell you how to do this. And the idea, the order is so that all your spacing is even. And so we're going to run a 0 to 14 scale here in the middle. And to do that, we're going to start about the middle. The middle is fairly easy to figure out. So you're going to take your green colored pencil, and somewhere in the middle, as close to the middle, you're going to put a 7. That's it, a 7. And so the 7 goes in the center. And then we're going to do the acid side first, which will be from 0 to 6. And so we're going to split all these in the middle. And so in the middle would be 3. So between the 7 and the bottom, I'm going to put a 3. Between the 3 and the 7, I'm going to put a 5. And then I'm going to fill in 4 and 6. And then I'm going to do the same thing on the bottom. Between the 3 and the bottom, I'm going to put a 1. And then I'm going to fill in the 2 and the 0. So I have some decent spacing between all of these. Does it have to be exact? No, absolutely not. This is just a range. And so now I'm going to do the base side on top, same basic way. I'm going to do 11, 11 somewhere in the middle here. And then between the 7 and 11, I'm going to do a 9. And then I'm going to fill in 8 and 10. I'm going to do the same thing on top, 13 in the middle, and then I'm going to fill in 12 and 14. So ideally I have 0 to 14 fairly evenly spaced all the way throughout. So now I'm going to open the right flap, and where I have all these blue squares, that's where you're going to draw some pictures over here, okay? And so again, we're going to start in the middle just to work on our spacing and go that way. So on the middle picture, you're going to draw the hydrogen ion concentration. I'm going to use my pen or pencil for this, just kind of in the middle. I'm going to draw a little container, and then in here I'm going to have the H pluses are going to be the same quantity as the OH minuses. And then you can draw a little, because all these are going to be in a liquid solution. So that one goes in the middle. At the very bottom, we're going to do the same thing, but notice all of these are H pluses. And just again, somewhere at the bottom. So all of these will be H plus. And the little brackets mean H plus concentration, or when we talked about molarity. So we're looking at concentration of H pluses. And so this is the acid side. All the acid will be, if it's a really strong acid, it's going to be all H plus ions. I'm going to get my little water in there too. Now at the very top, it's going to be all OH ions, hydroxide. And so you're going to have 4 OH negatives. Get my little water at the top. And then in between, you're going to have an in-between. So between the neutral in the middle at 7 and the fully acidic one, it's all H pluses, I'm going to have some that is more H than OH. So again, just kind of in the center here, I'm going to have 3 H pluses and 1 OH minus. So there's more H pluses, so that means it's going to be more acidic than OH minuses. And then in the other gap, we're going to have more OHs. So these will just have 1 H plus and 3 OH minuses. Forgot my little water line. All right, so that's the right flap. And so inside this, the gap on the right side, we're going to look at how these are all equal. So at the 7 in the middle, your H plus concentration will equal your OH minus concentration. And so again, that goes right about the 7 area. At the top, at the pH of 14, it will be all OH minus. Minus. See, if you mess up, it's okay. At the very bottom, it's going to be all H plus, hydrogen ion. Now remember, those are protons, so all protons. Just above the neutral, it's going to be more hydroxide, so more OH minus, less H plus. And then at the top of the acid portion, it's going to be more H plus, less hydroxide. And so as you get closer to 7, one of them is going to decrease, and then they'll be equal at 7. And then at the top, at a pH of 14, it's all hydroxide. At the bottom, at a pH of 0, it's all hydrogen. So we'll close the right side now. And now we're going to do ion concentrations. And so we have pH, which is a reading, and then we do concentration of ions, which is a reading. And so we're still going to base it off this same scale. At the top, very top corner, I want you to put H plus, concentration with the little brackets. And then in the middle, you're going to put 1 times 10 to the negative 7. That's how many hydrogen ions there are per liter. And so that means at a pH of 7, my hydrogen ion concentration will be 1 times 10 to the negative 7. And so you'll see that pH will correspond to all these numbers you're about to put over here. And so we're going to fill in, again, even with our number here, we're going to have 1 times 10 to the negative 6, 1 times 10 to the negative 5, all the way down to 1 times 10 to the negative 0. Or 1 times 10 to the 0. Then we're going to do the same thing going up. 1 times 10 to the 8, negative 8. 1 times 10 to the negative 9. All the way up to 14. All the way at the top. And so this is going to be your concentration, which directly relates to pH. pH per hydrogen is what that H is for. On the other side, we're going to do hydroxide ion concentration. So at the very top left, put an OH negative in brackets, and we're going to do the concentration. And where you have a pH of 7, it also has 1 times 10 to the negative 7 OH ions, but that's the only place they'll be the same. Because remember over here, that's the only place they're equal. But as we go up, it's going to be all hydroxide. So that number at a pH of 14 is going to be opposite. So where I had a 10 to the negative 14 for pH, that's going to be 10 to the negative 14 down here on the acids, because the acid has very little to no hydroxide. So now your numbers are going to be opposite. So on acids, the hydrogen ion concentration is 1 times 10 to the negative 6, but the hydroxide ion concentration is going to go the other way. So this will be 10 to the negative 8, 1 times 10 to the negative 9, all the way down, up to 14. And so at a pH of 0, my hydrogen ion is 1 times 10 to the 0, which is 1 mole per liter. At my OH ion concentration, there's a little there, but it's so tiny, it's not really significant. And so we do the same thing going the other way. And so at a pH of 8, I'm going to have 1 times 10 to the negative 6 OH ions. And so at a pH of 14, my hydroxide will be 1 times 10 to the 0. My OH will be. And so what do these kind of look like in real life? And so if we put these up, 1 times 10 to the negative 14 has 13 zeros in front of it, whereas 1 times 10 to the 0 is just 1. That would be 1 mole per liter. And so if we flip it on the OH side, it's the same numbers, just the opposite way. And so a pH of 0 has very little hydroxide and a whole lot of hydrogen ions. And then at 7, they're both the same, the equal amounts. All right, so now on the left side, again, we're only doing 4 pictures on this side. So we'll start at the top, and on the right side on the slide, it has the 2 things you're going to draw. So here, I'm drawing OH negatives and then M. M is going to be for the cation that happens to be with the hydroxide. And I have 4 of each here, and they're all separated out. So it doesn't really matter where you put them. I just have 4 OH negatives with the brackets. Just kind of separate them out. And so this is showing that they're all dissociated. And I'm going to have 4 M pluses. And M is just kind of a general cation for whatever it could be, sodium, potassium, just showing that they're all dissociated and they're all separated out. And then on this side, we're going to write strong base. And these completely ionize or completely dissociate. So they don't stay together in compound, they separate. And these will be made of group, misspelled that, 1 and 2 hydroxides.
At this time, please take your attendance.
So group 1 on the periodic table, sodium, lithium, potassium, those, and then group 2, calcium, magnesium, strontium, mixed with hydroxides are going to make these strong bases. Next, we're going to have weak bases down here at a pH of like 8 and 9. And so these partly ionize. So that just means they're not going to fully separate. So some of these MOHs will still be together. And so the way I drew it, I have 2 MOH compounds. And then 2 of each, or no, 3 MOH compounds. Helps if I would count before I say it. And then 2 ions. 1 M ion and 1 OH ion. So they are only partly ionized. And then we're going to do kind of the same thing for the acids, but with the acids we're going to draw little dots. And so a weak acid, so a pH of around 4, 5, 6 will be a weak acid, partly ionized. And we're going to draw little dots. So the dots that are together represent atom or compounds that have not separated or ionized. And so you could technically do this for the hydroxides as well, but I just wanted to give you guys separate things. So I have 10, 6, 7, 8, 9, 10. So I drew 10 blue circles. And 2 of those circles are not going to be with dots. The other 8 will be. So I have 2 lone dots. And then I'm going to draw 8 dots that are with the blue circles. So I'm going to leave 2 blue circles by themselves. Yeah, it doesn't really matter which one. So here's my black dot that's by itself, and there's my blue dots that are by themselves. And all the rest are with the cation. And so that's partly ionized. And then for a strong acid, there are 7 strong acids, and these completely ionize. And then there's a list of those 7. HCl, HBr, HI, HNO3, H2SO4, HClO4, and HClO3. So those are the 7 strong acids, the ones you will come across. So you need that list. You don't have to memorize it again. you will be able to use this, but need to know about it. And so on this, again, 10 compounds, 10 black dots, 10 blue dots, but all of them are separate. And so just draw your 10 random black dots, or you can do however many you want to fit on there. Just keep them equal. So that's 8, 9, 10. And then my blue dots will just be elsewhere. All separated, completely ionized. And so that will be the pH foldable that you will have to use. You just need to know how to use it. We'll answer some questions using this directly, and you just need to be able to figure out what's where. Let me know if you have any questions.